Good afternoon, ladies and gentlemen. Welcome to the IC Taiwan Grand Challenge Unveil. It's wonderful to see so many of you here on site and online. Today, we're honored to be joined by Vice Minister Su Zhengang of the National Science and Technology Council, Director General Lin Deshen of the Department of Academia, Industry Collaboration, and Science Park Affairs, Professor Conrad Yang, the Chief Organizer of the IC Taiwan Grand Challenge and jury member, as well as our winning teams and distinguished guests. The IC Taiwan Grand Challenge is an initiative started by the National Science and Technology. It aims to bolster Taiwan's IC startup ecosystem and to attract global tech talents. This year, the third batch of IC Taiwan Grand Challenge has selected 8 outstanding technologies from 28 countries and a total of 150 technologies. Today, you'll get to see them all on stage showcasing their innovations. And before we begin, we would like to first welcome Vice Minister Su Zhengang from National Science and Technology Council to deliver his opening remarks.
Good afternoon, Commander Yang and the award-winning team from Sweden, the USA, Korea, Denmark, Taiwan, and all industrial leaders and guests. Welcome to IC Taiwan Grand Challenge Unveil. Today we also have a bigger group from Germany, Dresden, right? Big pause. Welcome. It's my great honor to be here with you for celebrating the outstanding results from the third batch of this competition. Since this competition launched in 2024, the NSTC has opened its door to global tech talent, attracting startups and innovators in IC and AI application to collaboration in Taiwan. I'm proud to say this initiative has already attracted over 350 teams from around the world and domestically. From a highly competition field of 150 entries in this most recent batch, we have selected the eight exceptional teams. Let me offer my warmest congratulations to each of you. And the NSTC will provide comprehensive lending support for all the selecting 8 teams. Connect you with Taiwan's world-class industrial ecosystem by leveraging Taiwan's critical role in the global ICT and semiconductor sectors. We aim to co-create the future with international talent and accelerate innovation across industries. The breakthrough technology we are showcasing today, including semiconductor processes, AI chips, smart healthcare, sustainable architecture, 3D printing, and satellite communications. Later in the networking section, I encourage everyone to interact and dive deep into these teams' innovative technologies. I believe that by the synergy between Taiwan's industry and these world-class teams, we will spark new ideas, creating more opportunity for every industry's upgrade and cross-border collaborations. Finally, thank you all once again for your participation. I wish this event every success and all of you the very best in your future as we build a more innovative tomorrow together. Thank you.
Thank you for your encouragement. 有请苏副留部啊. Please stay for a moment. Before we move on, we would like to take a group photo to mark this special occasion. And in just a moment, we will invite Director General Lin Deshen and Professor Conran Yang, as well as our winning teams, to join us on the stage. And first, let's welcome Director General Lin Deshen to the stage. And next, we will welcome Professor Conran Yang to the stage. And now the winning teams, please come on stage when you hear your name. Fanto AI, HyperXL, Deep Mentor, Alex Labs, Brilliant Silicon Technology, Endosemio, 3D Architect, Pure City, Okay, now everyone, please look at the camera in the front. 请看向前方的摄影师 And with your smiles. 好，请各位要记得微笑哦。Okay, so now we'll have a second photo. Please give your thumbs up. 好，请帮我们比个赞哦。Okay, one more shot. 好，再等一下，我们后方呢，还有一些动态的要来录影哦。So keep your poses. Thank you. Okay, just one more. Big smiles. Okay, thank you very much. Perfect. Please return to your seats. The IC Taiwan Grand Challenge welcomes startups, university teams, and individual innovators working on IC design and chip-based applications, especially in AI, smart manufacturing, smart mobility, medtech, and sustainability. And now the moment we've all been waiting for, the award presentation is here. And now first we will welcome the 3 winning teams under the categories of AI core technologies and chips. Our first team is from the US, Fanto AI. Their full-stack solution spans custom AI, accelerated silicon, and production-ready algorithms, co-designed to bring real-time intelligence to everyday devices. We'll now welcome CEO Sam Folk on the stage. Please give him a round of applause.
Thank you. Thank you. Hello, everybody. We're honored to be here as part of the IC Taiwan Grand Challenge program, Batch 3 winners. It's very great to be recognized that this is a valuable contribution, and we're here to share with you a little bit of what we do. So we are Femto AI, and we are here to put intelligence in literally every device. And what I mean by that is that there are a lot of products that we use in our everyday lives, things that we wear, things around our home, things in our work. And all of these products, or at least the product developers that are making them, they want to put AI in them. Now, of course, there's some challenges to that. Really, it all stems around just how big AI. So AI is very large, it's very unwieldy, it's huge power consumption, and at least for these devices, it's very hard to get them deployed. So this is why we exist. We're here to basically take some of the power of that AI that is really all focused in cloud deployments and then deploy it at the edge, because there's a lot of devices out in the world that could use this, and because it's very commercially interesting, not just for the functionality and value that it gives to us as consumers, but also, of course, to all the investors and the general ecosystem and industry. Our way of solving those few problems of size, power, and deployment really centers down on this underutilized technique of sparsity. So we basically help our customers or ourselves take large AI models, which need to be large because they need to learn how to do the tasks, and we help them shrink that down. Because as they learn how to do the task, a lot of the parameters, the activations in there, you don't really need them. This is very akin to us as humans, as we go from babies to adults, what we do in our own brains. And this is something that's not really served right now. So we optimize these models as they learn, so they can be very small. And then we also build the silicon that could take advantage of the fact that there's a lot of zeros in these applications. Whenever there's a zero, don't deploy silicon for that. Don't pull it out of memory. Don't do operations on it. Just leave it be. This allows us to deliver 10x wins in power, size, and speed to our customers, which makes a lot of these AI capabilities actually viable for everyday products. As I said, this is a little bit underserved. And a lot of these processors that exist, you do this technique, you go through all this work to optimize your algorithm, and then you don't see any wins at the end of the day when you actually measure it on the system. Because this kind of math, this sparse math, tends to be very irregular. Instead of a nice block of matrix math, you're working with a little bit of Swiss cheese. There is stuff to optimize in there, but because it's irregular, you don't really see a benefit. This is why we exist as Femto.AI. Now, this technology has already made its way into real products. So our tiny little sparse processing unit 1 is already available. Welcome to buy it. As you can see, it's very small, but it's very mighty. You can deliver a lot of compute in a very small package. So this solves all of those pain points that customers are actually facing. But even beyond the silicon, this is just as much a software and application product stack as it is the IC design itself. So our customers, they get to work with our tools, and they also get to work and use and deploy the features that we have built. This full stack offering allows our product not just to be sort of a lab exercise, but it allows our product to actually make its way into real products, such as this one. So this is a first AI over-the-counter hearing aid, which launched in March of this year, to basically deliver a very nice listening experience for people who might need hearing aids in places like cafes, this conference where it's very loud. This feature is probably the #1 requested feature for this class of products. We're demoing this over at our booth in the silicon section. Beyond the hearing aids, there is also a good demand for this in the home appliance space. So a lot of these product developers, again, they're thinking about how do I deploy AI capabilities in my end products. I maybe want to add voice interfaces. We have great collaborations putting together our AI accelerator with general purpose MCUs so you can enable sort of full features and next generation user interfaces for consumer electronics in the home. Beyond those two product deployments, really what this has been enabled by is sort of an unrelenting focus on the customer and more specifically the developers of the customer, right? So nice to have great technology, but if no one can use it, it's just nice technology. If you go to developer.femto.ai, create an account, sign up, you're more than welcome to play around and really try out these sparse techniques, see the tools, get an evaluation kit, and really figure out how to get this product into your product because there's just a lot of work involved, and you want to make that as easy as possible for your customers. Now, looking ahead, of course, this is just the beginning. We have our beachhead in audio, right? We have our minimum viable product, the SP001. We are doing the standard startup thing and learning from the customers to say, okay, well, what do you need next? Why was this hard to integrate? What could we do to make it more valuable to you? And this has basically set our roadmap over the next couple of generations where we make systems that are more flexible, easy to integrate, and scalable so that customers can continue to add AI features to their systems and add bigger AI features to their systems, which is the direction that everybody seems to want to go. So as I said, those products enable the future roadmap. Basically, we start in this little hearable market that a lot of startups like to start in a niche because it validates the technology. But then the question for us now is, well, where can we scale this? So until we'll go industry by industry, and until every device that could benefit from AI has AI, there's still more opportunity, and there's still more work to do. Now I want to focus specifically on what sort of Taiwan and the IC Grand Challenge program has really helped us do. Semiconductors are a very core part of our product. There's an AI inference accelerator that somebody is literally buying. Taiwan is really the central place in the world where these things get made, and so we've established a good amount of partnerships with OSATs, fabs, sales, and other ecosystem players to help bring this to reality. Frankly, this is probably a program that really would have helped us when we started years ago in 2018, straight out of grad school. But we are not alone in this journey. We are joined by our great set of investors. That's a growing list. We are starting to get recognition because people are recognizing that, hey, a lot of AI things kind of get stuck in prototype. What's it going to take to really deploy on the world? So you're going to need some new technology to make that happen. So we're getting those recognitions. And of course, we have a great team. Beyond just myself and my co-founders, Alex and Scott, basically fresh out of grad school at Stanford Brains and Silicon Lab, we have surrounded ourselves by industry experts and veterans, and of course, those ecosystem players in Taiwan to help make our products a reality. So with that, I'd like to thank you guys for your time and the recognition. Please join us in our journey as we bring AI into every device. Visit us over in the booth there, follow up after the show, and thank you very much again to the IC Taiwan Grand Challenge program.
Thank you for sharing. Please return to your seat. And the next winning team is from Korea, HyperXL. HyperXL creates semiconductors and solutions for generative AI, empowering a world where advanced technology is accessible and beneficial to all. And let's welcome Principal Researcher and Co-founder, Sunjae Moon. Please give him a round of applause.
Thanks for the warm introduction. I'm Sunjae Moon, co-founder and principal researcher at HyperXL. And today, I'm greatly honored to be here as part of the IC Taiwan Grand Challenge to be selected as the winner in the Silicon area. And I hope to share that our technology will be at the forefront of the future AI semiconductors. So today, my topic is on the LLM processing unit, which enables efficient and sustainable generative AI with large language model inference accelerator. So just to quickly introduce our company, we were founded in 2023 January, very young, and this company was formed based on academia, and we formed our first product based on AMD FPGAs, and they really liked our technology, so they actually co-market and formed a partnership with our first product, FPGA-based product called Orion. And as you can see, that product was launched in October. And based on customer input, since FPGA is very resource limited, we decided to, let's really target the cloud data centers. And that's why we started to make our own ASIC based on our core technology, which we branded as LLM processing unit, or the LPU. And based on that, we actually got our PPA, the power performance area of our MPW, and we got some high praise from different cloud service providers. And that's why we formed a joint development agreement with Naver, which is the biggest data center in Korea. And now we're taping out our first chip, Bertha, based on our LPU technology. To briefly explain why what we're doing is very important, there's obviously the dominance of large language model services that is happening right now. As you may all know, ChatGPT has been on the rise in the AI technology industry, and the models are growing way bigger than what we can expect. And the hardware currently being used, the GPU, is very costly and heavily requires high power consumption. And for example, ChatGPT spent around $60K per month for their ChatGPT platform. And as you can see, there's some huge issue that we need to resolve with our hardware. So yeah, there are GPUs, but how is large language model different than other AI technologies? For example, training and CNN inference, it requires large training data sets and complex image matrix, as you can see in the middle with the convolutional neural networks. And therefore, they're very compute intensive, and the throughput-oriented hardware like GPU does really well for these tasks. However, large language model has a very different characteristic, that the inputs are simple vectors, and they're very memory intensive because they need to constantly load very large language models. And therefore, latency-oriented hardware is what is required. So currently, GPU is being utilized. Fine, they have many CUDA cores, as you can see from the technology here. And they have very complex hierarchy for programmability. And they have powerful hardware specification. Therefore, they're very good at what they do, providing high performance for parallel computation, for large data sets required for AI model training, and also for image inputs and CNN inference. However, these cores are very underutilized during LLM inference, and there's huge power waste during those workloads. And obviously, the high cost of the device and operation is becoming a severe issue. That's why at HyperXL, we target LLM inference only, and we hope to mitigate and relieve some of these issues that are coming up. That's why we developed the LLM processing unit, or the LPU, the world's first hardware dedicated for large language model inference. Now, how is this LPU different from the current GPUs? Our first feature is the streamlined memory access, where we perfectly balance the memory bandwidth with the compute bandwidth, which means we can maintain the bandwidth utilization up to 90%. Whereas the discrepancy between these bandwidth in the GPU, when you actually measure it from end to end, we only see that the GPU is getting utilized only 50 to 60% of the time. Also, because of this technology, we're able to replace the highly power-consuming and very expensive HBM with our LPDDR5X technology. Now, that compute data flow can get you, only to some places, but it's our optimized compute data flow that goes in complementary to our memory access data flow. As you can see on the left, this is a traditional GPU data flow where from the off-chip memory, because of that discrepancy, there needs to be a lot of intermediate data storage and a lot of compute unit back and forth. There are thousands of CUDA cores that need to be used for this LLM inference, but that's why some of the operations are done in some of the PEs, and on the next one, it needs to be stored back into intermediate memory and then bring back for the next operation. However, in our technology, we create LLM optimized data flow, as you can see on the right side. Very large cores that is streamlined for LLM operations, so that once the model is loaded to our cores, the entire LLM inference can be done at once. As a result, what happens is that we actually get up to 4.7 times higher normalized performance when compared to NVIDIA state-of-the-art GPUs. As you can see, our LPU only has 768 teraflops. However, our tokens per second is actually up to 1645, whereas the NVIDIA GPUs, they have around 2,000 teraflops, but they only are able to reach around 804 tokens per second. And we have other technology as, for example, communication advantages. Whereas older communication requires computation and communication to be done in a segregated manner, our technology, since we're software-based, we're able to really know when the communication needs to happen, so this computation and communication can overlap to significantly reduce the latency that is required during inference. And obviously, yeah, creating a good chip is great, but it's no use if you can't use it. That's why we really focus on the software stack as well. Obviously, GPU has created a great ecosystem using their CUDA kind of kernels and CUDA language, and that's why at HyperXL we develop at the same level of software stack from the hardware stack and the full stack, for example, device drivers, and connecting to the VLLM framework. It has really simplified the use of our LPU technology. So this is the technology that we are building, the Bertha Cloud and the Bertha Edge, using Samsung 4 nanometer and TSMC 6 nanometer technology. And since our architecture is very scalable in any domain, that's why we are able to create products that target both the cloud and the edge. And the performance for the Bertha Cloud that is coming out next year is the following. It actually has 2 times the throughput than NVIDIA H100 and has 2 times better scalability. And as a result, we get a whopping unprecedented cost efficiency of around 20 times better cost efficiency, also along with 12 times better power efficiency. And our technology has been recognized with our MPW validation, like I mentioned, and also we were awarded the IEEE 2024 Best Paper Award. And now we're finishing the tape out of our Bertha cloud. And this is an example of our LPU versus the NVIDIA GPU. On the left side, when running Llama 3.1 8 billion model with the same prompt, you can see that our latency is much faster than what Meta offers with their NVIDIA GPUs. So if you ask it a little bit more difficult question, like writing code, you can really see the difference between the latencies. And like I said, we're targeting both cloud and edge data centers. And this is the product roadmap that we have. Starting with Orion, we have done the MPW, and now we're doing mass production of our cloud chip. And we also have, for home appliances and increasing our domain, we have a on-device chip being prepared as well. So this is some of our partners. We have been preparing really well for this, and that's why we have a very heavily named and a very renowned hardware and software collaborations that are underway. And we are collaborating with Taiwan, as obviously Taiwan provides the best AI infrastructure in the world to make our LPU product come to life. And after our design, the AI manufacturing in Taiwan will make us a highly validated company around the world. In conclusion, we create the LLM processing unit, a processor that is very efficient, and we designed the most optimized hardware design. And the cost and power reduction for widespread of innovative AI service will be able to make our hardware be adapted in different domains so that it is the most efficient. And I believe that our partnership with Taiwanese companies through Ictgc will be able to really boost our confidence in our products and make a really great impact in AI industries around the world. Thank you.
Thank you for insightful sharing. And next is the winning team from Taiwan, DMentor. DMentor miniaturizes and hardens AI models into efficient chips for secure, real-time, and edge intelligence. And let's welcome CEO and founder Jack Wu. Please give him a round of applause.
Okay, thank you, Jesus. It's my honor to have the opportunity to join the Ictgc and win the honor. And so far, you are very curious about what DMentor do. DMentor is a company we found in Taiwan. We are from the National Tsinghua University. And what we do is we try to bring the cloud AI into the edge. So about 7 years ago, we established this company, and we try to help our customer to bring their cloud AI algorithm into the edge IoT devices. As you see, when we do this, we will meet lots of problems. The first problem is we find lots of our customers do not have the good quality of data. So the first step of our DMentor is try to help our customer to have automation tools to clean and to do knowledge stealing of their data. So the first step we do is we create the tools for our customer to clean their data. And the second step we want to start the pain point is even the customer has a good data, they do not know how to train this model. So the second step we do is we try to miniaturize the model and make the small model to have the same ability with the large model at the specific domain. And the third one is our customer they do not find any suitable chip for them to use at the IoT situation. So the third step we do for our customers is we try to help our customers to based on our automation design tools to convert our customers' AI algorithm direct into the chip. So our customer can have their chip in a very short time. Usually, based on our design, you will see our customer will get lots of the advantages. The first one is we use the miniaturization technology. This technology can save lots of the computation and the memory bandwidth. besides, it still keep the accuracy. As you see, this is a experimental result for our customer. You will see your left side is use our miniaturization technology, and the right side is use the pruning or quantization. You will see the accuracy is very different. And in the corner case, you will see the miniaturization technology will have a better performance than others. The other we provide for our customer is, before our customer adopt our technology, they usually use the NPU or the GPU to do their IoT case application. But they find even the NPU or the GPU, the utilization ratio is very low. Well, take for example, usually our customers will have 10% to 30% NPU or GPU utilization in their case. This case will force our customers to adopt the advanced technology about 4 or 5 nanometers to make their own chip. But this is not a good case for the edge AI deployment. So DeepMentor provide another approach for our customers. We first is focus on what kind of algorithm our customer want to use. And we directly convert the AI algorithm direct to the ASIC finite state machine. It means the ASIC is designed for this algorithm. By this approach, we can increase the chip's utilization from 30% to almost up to the 90%. So what does this mean for our customer? That means our customer can use the mature technology node to make their own AI chip. That's why our customer like us a lot. So far, you will see this is like a technical speech, but in fact, we help our customer now to build a multi-modality AI chips for the edge applications. And this is a chip you will see in the next year. And this chip is a speech-to-speech multi-modalities chip. What does this chip do? This chip can become a next generation human and the machine interface. Okay, we can show the little video about what this application does.
Hi, my name is Daniel. What's your name?
Hi, Daniel. How can I assist you today?
Could you tell me what is Newton's second law of motion?
Newton's second law of motion states that the acceleration of an object is directly proportional to the net force acting upon it and inversely proportional to its mass. This means that the more force applied, the greater the acceleration. Essentially, the more you apply the same amount of force, the greater the acceleration.
Oh, I see.
I'm glad to hear that. Is there anything specific you'd like to know more about or discuss further?
Could you tell me what is the formula for Newton's second law of motion?
Sure. Newton's second law of motion states that the acceleration of an object is directly proportional to the net force acting upon it and inversely proportional to its mass. Essentially, the more force you apply to an object, the more it will accelerate. This means that the greater the force you apply, the more force you need to change your speed or direction to achieve the same acceleration.
Oh, I see. Thank you for your answer.
You're welcome. If you have any more questions or need further assistance, feel free to ask.
Well, as you see, the function already is, we will implement in the commercial chip. But next year, you will see all the chips dimension will become a small one. And you will see we build this chip for next year, and you will see we use the same chip for different applications. And all these different applications, like senior care or smart cabinet or even the toy, we use the same chip, but use the different training data for this. So we can build a very strong human and machine interface for next generation application. Our business model is a little different from others because we license our IP to the chip vendor. In the same time, we also license our tool chain to the product makers so they can develop their product at the same time. So far, in our best case, we can shorten the developed product cycle from the 24 months within become the 9 months. And we also provide a complete tool chains, not only the IP solution, but also the AI, the tool chain platform to help our customers to do the AI model training and fine-tuning and then deploy to the AI chips. This is our model's application. You will see, we can see a little video about this model.
Extracts key insights from vast document repositories, enabling smart Q&A and efficient document retrieval. Combined with data expert and fine-tune expert, clients can customize AI model refining and knowledge distillation according to specific domain requirements. Together, we deliver perfectly tailored AI systems. From document processing to knowledge extraction, from model training to system deployment, deep mentor.
Okay, you will see we put all these tools together to help our customers to build their own AI application in a very short time. This is a real case example we already applied in the Taiwan city and the Taiwan government and the Taiwan hospitals. Okay, this is the reason why our customer likes our Deep Mentor, because we provide a very good semiconductor portals for our customers. For the AI training, we cooperate with the NVIDIA. For the AI's IP provider, we cooperate with the ARM to provide the wholesale AI IPs. And to do the prototyping, we cooperate with the AMD to provide the fast prototyping FPGA. And if we want to tape a chip, we cooperate with the NVIDIA, the Synopsys, and the TSMC to provide the fast shuttle and MPW project for our customers. This is why our customer like us very much. And thank you, our government give us this opportunity for us to introduce Deep Mentor to the worldwide companies. Thank you very much. I'm Deep Mentor.
Thank you very much for sharing. We really appreciate it. And on the next, we will have our winning teams under the categories of smart manufacturing. First is Alex Labs from Sweden. They will talk about APS, a disruptive and sustainable method for advancing semiconductor scaling, reducing cost, energy consumption, CO2 emissions, and water usage. Please give them a round of applause.
Thank you very much for the nice introduction. Indeed, it is a great honor for us to be among the winners of IC Taiwan Grand Challenge. And it is a pleasure for me and my team to represent Alex Labs. We are coming from Sweden. We are Swedish startup working on semiconductor equipment manufacturing. It might sound a little bit strange, Sweden, semiconductor equipment. Sweden doesn't have that much of background in semiconductors, but if you here 10 minutes, you will find out more. So we are a spin-off from Lund University. At the moment, we are around 14 full-time employees. Our headquarters is located in Lund, Sweden. We have a clean room over there, but we also have an office in Dresden, Germany, another office in Eindhoven, Netherlands. We have a full-time representative in Taiwan and also in Japan. So we are in Taiwan, Silicon Island. The most advanced technology is built here, electronic chips. It has enabled us to come a long way toward digitalization, AI, Internet of Things. And we need more advanced electronics to even further process the data even in a faster way. However, according to TSMC, every time we are going to a smaller node size, the cost of fabrication increases substantially. According to this image, when we are going from 2 nanometer to 1.4 nanometer, the cost of fabrication increases at least 40–50%. And why is that? Because if a single chip to become from silicon wafer to the full production, it has to go through at least 3,000 of steps. And that is huge, 3,000 steps of extensive, expensive equipment. So in this example, there is a lithography here, and then deposition, etching, cleaning, trimming. And the consequence is that us, normal people, we have to pay a lot of money for next iPhone, cell phone, laptop. In Alex Labs, we found a way, a very disruptive way that if we use plasma, we can replace so many nanofabrication steps with a single equipment. So the fabs and foundries, they don't need to invest in heavy equipment and costly equipment, but instead they can invest in Alex Labs APS technology. We call it APS, atomic layer pitch splitting. We have around 20 patents around this technology. It is implemented in our tool, and the idea here is to commercialize this technology. The value proposition is that the customer for us are foundries and IDMs like TSMC, Samsung, Kioxia, UMC. And what we offer is that we offer the same nanofabrication, less equipment, and then what we say is that you can achieve the same node electronics, go to even smaller dimensions, all in lower cost, lower energy consumption, lower CO2 emission, and water consumption. It might look very interesting, right? There is a technology here that can be reducing the cost of fabrication a lot. But issue here is that for us as a startup, penetrating this market is really, really difficult. Semiconductor market is already established, and each foundries, they have 20 years of research and development behind there. So for us to attract the attention of the foundries, we have to compare ourselves with the state of the art. And the state of the art is EUVL. So here I have 3 images: Alex Labs APS technology, low NA EUVL, and high NA EUVL. And there are some metrics here: CD, half pitch, line width, roughness. The point here is that we can achieve the same results, same resolution as low NA EUVL. We are not there yet with high NA EUVL. However, we believe nothing is stopping us to achieve that. We are mostly doing R&D, and we are sure that we will be there quite soon. The point of this slide is that that system is around 500 million euro. This system is around 300 million euro. This is just a fraction of the cost. So that's why we have lots of traction globally. So we are collaborating with the companies all around the world. We are collaborating with Intel in US. We are collaborating proudly with UMC in Taiwan, and we are helping them to go to a smaller node size in a lower cost. There are other foundries in Taiwan that we are collaborating, as well as companies in also South Korea and also in Japan. The example with UMC is that we receive a demo request from them. This is as received wafers. We receive these wafers from them. They are the foundation for 12 nanometer nodes, I believe. And in one go, we double the density of the patterns, which otherwise UMC has to do lots of nanofabrication steps to achieve the same data. We have finished several phases of nanofabrication, and we are going into the next phase. So this is something that we are really, really looking forward. We are very grateful to UMC. Our product, the first 300 millimeter APS ICP RIE system here, our colleagues placing a wafer inside it. We have done all the demos with this tool. However, this is just a prototype. It doesn't comply with automation or contamination level of the foundries. That's why we are manufacturing a cluster tool, multi-chamber system, fully automated in compliance with all the contamination, throughput, yield requirement from the foundries. We believe that will come in line in 2026. Of course, this industry is very expensive. We are raising funding at the moment. We are raising a Series A funding around 15 million euro. We are almost done. There is still some room remaining, around 1.5 million euro. We have got a new CVC from Japan this round, and there is still room available. So we would be happy to talk to you if there is interest from your side, if there is any question from your side. We have our booth over there. So please feel free to come to us, and we are looking forward to talking to you. Thank you so much.
Thank you, CTO and co-founder Amin Karimi, for your sharing. And next is Team Brilliant Silicon Technology from Taiwan. Their topic is Alley of Satellite Chipset, integrating RF, efficiency, and smart computing to drive high-speed global satellite communications. And now let's welcome Director of Technical Marketing, Ming-Feng Lei. Please give him a round of applause.
Good afternoon, everyone. I'm Mingfeng Lei, and I represent Brilliant Silicon Technologies. Today, I'm going to talk a bit about our LEO satellite chipset and how this is going to be used in the user terminal. A quick introduction of Brilliant Silicon. We are established in 2022 with a strong team of members from all over the industry in Taiwan and also in US. We have over 10 PhDs covering various aspects of the system, such as circuit design, wireless communications, neural network, and also software and firmware development. I think a strength of our team is that we have design and mass production experiences in from 3G to 5G cellular, NB-IoT, Bluetooth, Wi-Fi, and also GPS and radar chipsets. We currently have a product line of Bluetooth chips and IPs. So if anyone is interested, also we are happy to talk. Okay, so the main topic. So this is an overview of a low Earth orbit communication system consisting of satellites, ground stations, and also user terminals. And we believe that I think with data communications, wireless communications, this is I think the one of the few topics, and I think one of the most typical topics also. Due to the fast movement of the LEO satellites, they move across the sky in about 5 minutes. So it's necessary to use an active antenna array to connect with the satellites. Okay, so the challenges of this user equipment is that you need a very big array. So up to, I would say about up to 100 to 200 chip element is required to assemble such a array. Currently, most of the products in the market are a 4-channel, 8-channel design, so this would be a very high cost. And the chips providers right now, they are guaranteed to chip out. And oftentimes, they have to work with the SI to get the entire system ready. Sometimes, or actually, I think this will be more common, is that there are many different satellite systems. They have different specs. So sometimes you do need more power or better noise for your system. However, these circuits are not designed with the appropriate LNA or PAs in mind. So for the SI, they are limited in their choice. So these challenges contribute to the high cost and the complexity that we see right now. Okay, so this is BSI's approach. So there are three considerations. The first consideration is that we are using commercial CMOS process. They can be produced in high volume with very high quality, and we are also leveraging. Because this is CMOS, they have a lot of, it is possible to do a lot of digital circuitry on the chip. And this can assist the chip for calibration, compensation, and also automatic controls. We are also improving the circuit efficiency. So reducing the active current, the performance, the efficiency, and also the leakage power of the chip. And we are also introducing power-saving techniques that's often seen in Bluetooth, Wi-Fi, and cellular chips. And we are also designing our chipset from the system level. So we are going to, this is designed with component reuse, block reuse in consideration. We support both FTD and TDD systems. And the design core itself is usable on Earth, the user equipment, as also as in satellite. And we are also designing our RF front end and our beamformers together in tandem to reduce the overall cost. Now, we're designing 2 chips. So the chip on the top is a beamformer. This is a 1 to 16 beamformer. We're targeting KU band, which is 10 to 15 gigahertz. This is a 1 to 16 channel chip, TDD, so this is both used for the transmitter and the receiver. On the beamformer itself, we also integrate the LNA and the PA. We are also designing RF front end, which consists of LNA and PA, and this would be matched in design to our beamformer, and we will see in the following page why this is advantage or has an advantage over the other components you see in the market. So this is a comparison of a few of the competitors in the market. BSI is designing our technology, our chip in CMOS. We have 16 channels for each chip. Our chip works for both transmitter and receiver. So some companies do it as separate part, some companies do the same part, but the advantage is that for the SI and for your system design, you can use the same components. We have a higher output power. We have excellent noise figure. And we are designing our front end co-designed with our beamformer. And there are some tricks and some things you can do with such a design. Okay. And some additional features, as I mentioned before, we're using CMOS process. So we are going to use the digital part of our chip for extensive applications such as calibration, temperature compensation, channel compensation, and there's a lot of memory on it. So we can build larger arrays without the complexity of the system. There are also some splits to the beamformer chips, which I listed here, but I won't go into detail. Furthermore, the RF, we can do some tricks, or we have several different RF front-end designs to apply to different systems. I think the most obvious difference would be different systems at different orbits, which will need a large power or smaller power, like that. So this is the reference design. So in tandem, the beamformer in tandem with our front end, we can use a lot less beamformers. And for this 16 by 16, 256 element array system, we can do this design with one beamformer, and those would be 128 RF front ends. This is not quite obvious here, but we can see in the next page, this is a cost experiment or a cost analysis that we did just based on the transmitter. But if we look at the third row and the fourth row, you can get a lot better performance with one beamformer, a lot of RF front ends compared to just with beamformer. Or if you look at row 2 and row 3, you can get the same amount of transmitter performance, but at about 60% of the cost. So that is our KU band design. We're also investigating how to realize this architecture in KA band. So KA band is about twice the frequency of KU band, so there are a lot of challenges. The chip, actually the board, the system itself will be a lot smaller, but you would have to deliver a lot more power and at the same area. So this is a big challenge. Some approaches that we are considering are doing the beamformer and the RF front end into a single package, and also integrating antenna with the beamformer design, or make the beamformer antenna as a module and design this as a tile approach. This is my presentation for today. Thank you very much.
Thank you for sharing. And on the next, we will have the winning teams under the categories of smart manufacturing. Ando Semio from Taiwan. Ando Semio's AI-powered ENT endoscope combines narrowband and wide light imaging to detect early signs of nasopharyngeal cancer. And now let's welcome the CMO of Ando Semio, Ruby Hong.
Hi,
Please
everyone.
give her a round of applause.
Hi everyone, I'm Ruby Hong, Chief Marketing Officer of Ando Semio. So Ando Semio is a startup focused on miniaturized endoscopy innovation, and we are going to turn the invisible visible in the clinical setting. So we are honored to be the first winner of MedTech Startup in IC Taiwan Grand Challenge. So we are going to share how a young MedTech startup like us are going to reshape the early cancer screening by combining the deep clinical insight with the semiconductor precision. So a little bit about who we are. Endosimio is a spin-off from National Taiwan University. So we are a result of technology transfer from NTU, and we are co-founded by clinical professional Dr. Lin Zhipeng and another medical commercialization expert, William Chen. So with this dual engine, we are going to make a huge progress. We have already submitted FDA and also have some global recognition around the world within only 2 years. So despite all that, we have one mission, simple but very ambitious. We are going to make endoscopy image smarter, safer, and more accessible for all people. So that is based on our core technology. So we have the full control of the insertion tube of the endoscope, and to be more specific, that is one, the coating technology for the tube, because the insertion tube is the part that put into your body. So the biocompatible coating material is really important, and we have the know-how for that. And the second one is that we have a miniaturized imaging package for less than 1 millimeter that consists of CMOS sensor module, the camera module, and also the LED light, and also the tube that mentioned to less than 1 millimeter. So that helps the physician to navigate inside the human body and also perform the surgery precisely. And the third one would be a plug and play design for our endoscope. So that allows us to have a single use or individual usage endoscope. So that eliminates the cross-contamination. That is an important issue for the past few years. So from that core technology, actually our application has a wide usage from ENT, uroscope, and neonatal. But now we are going to dive into the computing power from hardware to software integration of the AI box. That's today's topic, the nasopharyngeal cancer. But you definitely will wonder, what is nasopharynx? It's actually, when you look at the picture here, it's the part hidden behind the nose, so it's really hard to detect. It's the early symptoms are often mistaken as flu or allergic, so it's not until the late stage, like stage 3 or 4, the patient go to the big hospital to get diagnosed. But as you can see, the survival rate dropped down to only 30%. So the early detection is actually key to NPC, the nasopharyngeal cancer, and it's actually a very common cancer in this area where we are right now, for East Asia or Southeast Asia. And the reason for that, according to the journal, is because of the genetic and also the lifestyle choices in this area. So we are also talking about millions of people around here as well. So early detection is key, but current tool actually falls short. So current tool is either, today's option is either blood test, the biochemistry with only 20% of accuracy rate, and the other option is actually by direct visualization based on the experience of the physician. So it's really hard to distinguish from the tumor tissue to the normal one. So our solution has several steps. So we have the ENT endoscope that we have, but we will enhance the vascular pattern with our NBI narrowband imaging technology, and then put it into the AI model. It's all real time to circle around if you have the potential for the early cancer symptoms, so that you can transfer to the big hospital. I guess I can put it more straightforward. So from our camera, we will first enhance the vessel in your mouth. So you can see clearly if there is a vessel increasement around the tumor. And according to that pattern, we'll have an AI model to circle around if you should go to the bigger hospital for a deeper examination. So here is a demo video that I would like to show you if you don't have the time to go to our booth. Please play the video. So now you can see that's our ENT, and that's current AI box. The left-hand side is original, and the right-hand side is the enhanced one, and our anonymous engineer. So you can see the right-hand side is actually the vessel is enhanced, so that's easier for the doctor to see the difference. Okay. So again, we would say that our position is for early detection. So it's easier, as you can see in the monitor on your right-hand side. So we can circle if that you have that potential for the early cancer symptom. And currently, we are lucky to be part of QITC, that's Qualcomm Innovative Taiwan Grand Challenge. So we are shrinking down the AI box at this moment to smaller AI box. It's easier for the clinics to use it. But we are also looking for more local SI integrators or semiconductor or CMOS sensor manufacturer to join us so that we can have a better solution to provide more passion. So right now, again, that our advantage lies in that we are a lightweight solution, so it's easier for the ENT clinic, the ear, nose, throat clinic to use. If you notice that in Taiwan, we have over 2,000 of ENT clinics, so if we can put it in that, it's easier for everyone to benefit. So it's not like blood tests or a really expensive endoscopy system that require higher costs for the clinics. So for the market, we in terms of the business model, we focus on the health check. So it's around like, we will focus on like 200K health check yearly in Taiwan, and also put it into the ENT clinic. And that will be a hardware sell and also a software subscription by each examination. So currently, we already have animal studies and also have 10+ physicians to have the usability test. And we are welcoming more. As I know, there are a lot of hospitals here today as well to join us as our clinical partner as well. So we were just founded in 2023, but we have made huge progress. Like last year, we submitted FDA. We are expecting the approval at the end of this year, and we already finished angel fundraising last year and looking for a pre-A fundraising at the end of this year as well. So in 2027, we estimate to have a break-even point. So last but not least, our team consists of a balanced background from clinical, technical to business scaling. So our co-founder, Dr. Lin Zhipeng, he's the anesthesiologist in National Taiwan University Hospital. So he will see the broadest range of surgery as he's the anesthesiologist. And William Chen, he's the expert for not only a regulatory pathway, and he's also the auditor of ISO 13485, so that's why we're fast forward so quick. So all in all, we are looking for more partners to join us, like clinical partners, SI manufacturers, and distributors. So thank you.
Thank you for your inspiring sharing. And up next, we have two winning teams under the sustainability category. First, let's welcome 3D Architect from the United States, a company revolutionizing metal manufacturing for greater energy efficiency. And now let's welcome the founder and CEO, Kai Narita. Please give him a round of applause.
Hello everyone, my name is Kai. I'm the founder and CEO of 3D Architect. And thank you so much for having me today and also selecting us as a IC Grand Taiwan Challenge on the finalist here. So we are a manufacturing startup located in the US in Boston and Sendai City in Japan. And we revolutionize metal manufacturing for the energy efficiency. So the problem we are tackling as a manufacturing startup is about the data center power consumption. As you heard probably a lot about in the news, a data center consumes tons of energy. So data center will consume 13% of all electricity by 2030. And it's such a huge number. Actually, the 40% of the total energy used in the data center is coming from the cooling. So the heat dissipation or management is actually a huge problem today. And it's actually $52 billion cost per year in the 2030. The reason behind is that the GPU power density keeps increasing. The AMD announced that this year it reaches 1400 watt, And actually, it keeps increasing. And this number is actually even higher than the heat dissipation density of the rocket engine. So you can imagine that the heat actually is a lot of heat is generated in the data center. And the data center's energy, the cooling solution is shifted from last year from air cooling to liquid cooling. And what they do, people in the industry, is that we located this copper cold plate that has a simple thin structure, and you put this one on the top of the GPU and you flow the liquid so that you can put the heat. And we see that actually there's a limitation for the manufacturing and design. Today's manufacturing process can only offer 0.1 to 1 millimeter design control. It's a very simple design, which is not really optimized, so that they only can offer inefficient cooling solution with limited liquid flow. And here, this is our technology comes in. We developed a new manufacturing technology that can offer 0.01 millimeter design control, 10 times finer design control with a sophisticated structure, so that you can offer the efficient liquid flow and 50% cost cut for the cooling. So if you think about it, if you scale globally, actually we can offer, just by replacing this cold plate in a liquid cooling module, we can offer $26 billion electrical saving per year. And this is enabled by our core technology. So we developed a totally new manufacturing technology to make a metal. That's called gel-enabled metal manufacturing. So this is a totally different way of making metals. We're gonna make metals, but we don't start from metal. So what we do here is that we have the proprietary gel material, which can be manufactured by lithography-based manufacturing process that's typically used in the semiconductor industry. It's very fast and very precise. And by using this technology, we can make a 3D structure by gel. We also have the very specialized post-processing that can convert gel to metal. So by using this lithography manufacturing technology of the shell device, with our gel chemistry and also conversion chemistry, we can create very, very precise 10 micrometer resolution metal products. And out of actually different companies in the metal 3D printing industries goes into try go into this market. And by comparing those like resolution, print rate, and printer cost, we see that we offer the best quality and throughput and cost. And the reason behind is that we actually see that we do the game change in the manufacturing. So if you think about heat sink manufacturing process, you typically start from selecting materials. For example, if you want to make a heat sink, think about probably you want to select a copper or aluminum or stainless steel. And once you select the material, you have to think about machinability, and that limits your design. So if you select the material and design in this shape of form, you always have to think about machinability, that constraint design. And we actually changed the way of thinking the manufacturing process. So we don't start from the selecting material, but instead we start from the design so that we can fulfill the demand of the, for example, cooling application. But if you make the very sophisticated structure like this in the design, it's really hard to make it by the material you want to work with in the end. So instead, we use very easy material that work with, which is gel material and light processing, so that you can create a 3D structure and then convert to the metal that you want to work in the end. So we start from the design and then select the material so that we can offer the complete freedom in the design, both design and material selection here. And this is a very breakthrough, and our technology is one that is recognized in the different articles, and one of the renowned ones is that the academic journal Nature selected our core technology as one of the 7 technology to watch in 2024, because our technology for the first time can offer nanometer or even micrometer scale design control in the metals. And our business model is that we are a seed stage startup and working with multiple companies and research institutes in Japan, US, and Europe. And Taiwan is a very important market. We are seeking some partnership in Taiwan companies, and we are shifting to the mass production in the next year and the 2 for the mass production. But in the end, what we are trying to do is the licensing of the not only the manufacturing process, but the architecture here. And our market is that we see $1.6 trillion market size. This is not only for the data center cooling, but also actually we can offer any fluid dynamics related devices, such as a hydrogen generation through the water electrolysis. And from the sum, just by selling the components, like cold plates for liquid cooling or a gas diffusion layer that uses the hydrogen market, you can see that $1.6 billion market opportunity. And this is supported by entirely our team located in Boston and Sendai in Japan. We have the 2 teams, the manufacturing and design, with our 8 PhDs from the renowned universities such as Caltech MIT and Harvard. You have renowned advisors from the tech and also business strategy from the people in the NVIDIA or semiconductor industry, CA executives. And we're well recognized in North America, Europe, and Asia. In Taiwan, we had selected for the Garage Plus cohort last year as well. So we are 3D Architect, and we are hiring. We are hiring a thermal expert and the materials expert in Japan. So if you are interested in work with us, with the talented people, and coming to Japan and Taiwan, please let me know. Please talk to me. Thank you so much.
Thank you very much for your sharing. And next is the winning team from Denmark, Pure City, which is the world's first AI-driven building eco-enabler. Let's welcome the founder and CEO, Mortisa. Please give him a round of applause.
Hello, everyone. Hope you're not too tired for the last presentation. I'm Morteza, CEO and founder of Pure City. We basically enable buildings to save energy, clean air, and add extra insulation into the building. The story of Pure City is basically very much personal to me. When I was a kid, I've lost one of my best friends due to the high level of air pollution in our cities. She got lung cancer and she passed away. Later, when I grew up and finished my education, I said, you know what, I need to do something about this. So I came up with the idea of Pure City. And as you know, air pollution is a global disaster. And buildings are majority contributors. As much as 40% of global energy consumption and CO2 emissions are coming from the buildings. And in the buildings itself, HVAC system consumes over 60% of the energy consumption in the overall building. So these two are basically the most important part of the whole consumption and CO2 emissions in the world. But we are turning this around. We have a new type of construction panels that it will be installed on the bottom of the buildings. It uses natural ventilation to suck the pollution inside. It cleans the air, and it cools down the air temperature. And then the clean and cold air goes all the way to the top of the building into the air conditioning system, which saves up to 60% energy consumption on the HVAC, and then the clean air goes inside the building. We, of course, use solar panels to supply the system, so the system is 100% sustainable. We are not using any other energies, and we are basically collecting the pollution, and we have a closed loop that we are recycling the pollution. We do that on one building at a time, and we go to the next, to the next, to the next, and to the next. You can take, you know what's going to happen next. So, we have implemented the pilot project in collaborations with Toyota Motors Europe in Brussels. The result of the pilot was significantly interesting. So what you see here is basically at a 29 degrees temperature, we are removing basically -5 to -7 degrees from the air temperature. What does this mean? Let me explain it like this. When you turn on your HVAC system and when you want to go -1 degree down, that costs you 6% extra energy consumption. And if you basically -5 degree delivering to the HVAC, this is simple calculation. You're basically reducing 30% energy consumption on the HVAC alone. This is one side of this, benefits of the product. This, what you see here, at a 29 degrees, direct sun on the panels. On the left side, what you see is basically the panel itself. It's about 22 degrees. It's basically colder than the normal temperature in the environment. And the left side, what you see is basically the wall next to it, which is 42 degrees. This is 19 to 22 degrees temperature reduction on the building. What does this matter is that usually during the day, how the building works is like, they work like a battery. They collect the temperature from the sun, and then this temperature passes the walls and the insulation goes into the building, and then it heats up. And that heating up, how does it, we will balance out? You increase the HVAC system. You keep pushing it down and down and down. This means consumption of the energy, more CO2 emissions. We are reducing that. We are getting rid of that. All of these things basically will result into about 60% of energy reduction on the building and about 72,000 mature trees CO2 reduction. Not a small tree, mature tree CO2 reduction per year. This is just one HVAC equivalent of CO2 reduction of our system. Our return on investment is between 2 to 5 years, which is fantastic. And our target markets are basically factories, airports, hospitals. This building basically is one of the target markets that we have. It's a $250 billion with 13% growth rate per year. We have manufacturing capabilities and scalability. It's located in Germany. Our business model is based to a kind of a win-win process. We are providing these panels for free to the building owner. We are getting we raise funds from the investments or the governments. We implement them for free. 2 to 5 years return on investment. We pay back the funds that we have raised. Then we continue producing recurring sales. This would produce a win-win situation for everyone because it allows a building owner to contribute to sustainability and bringing down the CO2 emissions on the building itself. Government contributing to this whole process, basically funding it, and us making money as well as contributing to the sustainability. Now, for the parts related to the whole program today, we have a reveal. So when we were doing the pilot implementation at Toyota, it was something interesting that we found out. We are using a lot of high quality and standardized basically controllers, PLCs, sensors from different companies. And integration of all of these sensors together and devices together to have one system that it actually works very fine, it's quite difficult. So what we have done was basically we built our own from the scratch part of the system. And this is for the first time, by the way, I'm revealing this. We have been developing so far for this process. So what happens is that as easy as you can see here, maybe not as fast as this video, but as easy as you can see in this, you can actually have your whole process designed. And then once you have the process designed, you will collect the data. So you have eyes on what's happening. And then at the same time, our hardware gives you ability to control. So you have hands and eyes. What do you need? You need a brain. And the brain is this platform. We will integrate basically AI systems and AI basically for the predictive analytics and predictive controls. So what's happening is that we can control the whole system, we can report it, we can take everything out, and we can see what's happening. All of these will result into a higher efficiency in the whole process. And this is for what? Basically for doing a carbon footprint optimizations of what you see right here, which it gives you, and you can actually enable it by AI. That's what we are doing right now, and we are looking for a smart investment and a strategic partnership. And I really appreciate and thank you all for the support and allowing us to be on the stage and give you this reveal. Thank you.
Thank you for your wonderful sharing. And that's all the winners for the third batch of the IC Taiwan Grand Challenge this year. And now, as we come to the end of today's event, we would like to once again welcome Professor Conrad Yang, the chief organizer of the IC Taiwan Grand Challenge, to deliver his closing remarks. Please give him a round of applause.
Thank you very much. This is the third IC Grand Challenge event. I personal experience from the first one to the third one. It's definitely getting better and better. And the quality, the result much better than the first time we pioneered. I'm also very happy because I have been through the 3 round of review, and I see more international involvement. This year we have US, we have Europe. Interesting is mostly from Northern Europe, Scandinavia, Sweden, and Denmark. And we also have Japan and Korea, and two teams from Taiwan. So this kind of event is really an international activity, put everybody together. I hope we have a Dresden group come here, a student group. Next section, hopefully, we will have a Germany company will join us also. So this is a platform to help all the global company to come to Taiwan as a platform to talk together. Basically, Taiwan is very, very strong in supply side. Taiwan may not be very strong in the demand side. The market is not very big, but Taiwan's market could play a very important pilot market. We are willing to try new things, and we can make the production in higher scale kind of things. So Taiwan is, in general, is a harmless and helper enabler to the global company, especially in technology area. So really welcome the international people come to Taiwan to work together as a partner. And I just listened to this all the presentation. It looks like originally I thought should it be a baby? No, this is not my baby. They are all grow up. You guys are very, very strong. So I look at each team as our partner, really as a partner, and we can work together to make your company become stronger and stronger to the global market. And I really appreciate your coming to Taiwan, and hopefully you feel Taiwan at home and enjoy. In October, this is not very usual weather. It's a little bit hot. Tomorrow it's going to be cooler. Hopefully you can stay for a few days to experience the cooler day of Taiwan. But it's going to be rain also. But anyway, so enjoy what you have here and talking to the people. We have this event, and hopefully National Science Council is not for investment, but this is a platform to attract the quality team come here. So attract the investment also from Taiwan, and global investment come to play, help your company also. Okay, that's all I need to say. Thank you very much.
Thank you once again, Professor Conrad Yan, for your encouragement. And now, everyone, please take a moment to scan the QR code on the screen and help us fill out the survey. Later, you'll be able to show the completion page and get a small gift at the reception. Quantities are limited, so be sure to grab yours before they run out. 那各位贵宾，现在我们的活动呢也已经进入尾声了。那邀请大家呢拿起您的手机呢，来扫描我们荧幕上的 QR code， 来协助我们填写问卷，留下您宝贵的意见。那完成后出示画面呢，就能在我们的报道处呢来兑换我们的精美小礼物了。那由于数量有限，送完为止，请大家把握机会。And in addition, if you're interested in learning more about the winning teams, you're more than welcome to visit their booth at the FUTEX IC Innovation and Applications area. We hope you enjoy today's award-winning presentations and wish everyone a wonderful day. 那欢迎大家呢，在我们的活动结束之后呢，继续前往 FUTEX IC 创新与应用专区来参观。那非常感谢今天各位的莅临，祝福各位有美好的一天，谢谢大家。